All right, so we're in Journal 14. I want to start off with just an easy bell work here about converting. So you guys have learned all different ways to convert, but I'm going to show you one method that is particularly more, more commonly used, especially when you're converting some difficult things here. So it's called dimensional analysis, which sounds really scary, but it's not. It's the idea that you're canceling out your units using ratios that have the same value. So what I mean by that is typically we would think, okay, if I'm converting from inches to feet, I need to know that 12 inches are in 1 feet, right? 12 inches are in 1 feet. Well, I can write that as a ratio. So what I mean is if I have 78 inches and I want to multiply to convert to feet, I would, well, first off, if you had 78 inches, if you want to know the feet, you would probably divide by 12 to get the number of feet, right? That's what normal people would do. But if you use this way where you have a ratio, well, you would think about, okay, well, I want to cancel out this unit, inches. So if I make this here, inches, there are 12 inches in a feet, 1 feet. So notice how I can create a ratio that says that 1 feet is equal to 12 inches. Now these two are equivalent. Now when I multiply straight across, the inches will cancel, the units for inches will cancel, and when you multiply, you would have 78 times 1 feet, which is 78 feet. And then the bottom here would just be 12, so we carry that over. But now it's just 12, no inches. So you would do 78 divided by 12, which is exactly what you guys would have probably have done. And 78 divided by 12 is 6.5 feet. And there we have it. We have converted from inches to feet. So this sounds like a long process, but when you're doing like really difficult conversion, it's all about, are you canceling out the units when you're converting? And this helps you cancel out the units. So like if I were to do feet, so I'm converting 4.5 feet to inches. And so what I'm going to do is use that same ratio. The only thing this time is that I notice I need to cancel out feet. So my denominator here needs to be feet. But I know that 1 feet is equivalent to 12 inches. But when I multiply, the bottom, the feet and the top and bottom will cancel out. And then when I multiply straight across, 4.5 times 12 inches is going to give me 54. Get 54 inches. And then the bottom here would just be 1. So if you have that over 1, well, 54 inches over 1 is just 54 inches. And so there we have converted our feet into inches. Okay. All right, so I brought up these skills because I want us to look at conversion, because we are going to be converting degrees into something called radians. You might have heard of me talk about radians a little bit, especially when you look at the calculators and you're switching modes. You have to switch from degrees to radians, radians to degrees. And so we're going to talk about what are radians today. So let's take a look at our next slide. So I want to just first take a look at how you would figure out the circumference of a circle. So back in geometry, you learned how to find the circumference of a circle. That is your formula C for circumference, 2 pi r. So when you take 2 pi and multiply it by the radius, which is r, you're going to get the circumference. And if you guys didn't know, the circumference is the distance around a circle, or the length around a circle. So what it says here is, what is the circumference of the unit circle if you know that the radius here is 1? Well, if I know the circumference formula, I can just plug in, oops, let me grab my pen here. I can just plug in 1 for r. So if I plug in 1 for r and multiply this out, 2 pi times 1 is just 2 pi. So that means that the circumference around a unit circle, and remember, a unit circle has a radius of 1. So if I have a unit circle here, let me draw one. Remember, unit circles on a coordinate system. So typically we think of this as 0 degrees, 90 degrees, 180, 270, and then we're back to 360. But it turns out if you travel all around the unit circle, if you go around the entire unit circle, the circumference or the distance around the unit circle is 2 pi. So 360 in a way, if you go all around, you get 360, or if you go all around, you get 2 pi. So what I'm saying here is that 2 pi is equal to 360 degrees. So the length around a unit circle is 2 pi, or 360 degrees. And then it says here, what is the length from 0 to 180? So what I'm proposing here is that I'm asking you guys, what is the distance from angle 0 all the way to 180? What is that distance or that length? Well, if you know the entire circle here is 2 pi, and if you're just asking to go to 180, isn't that half of this circle? So what's half of 2 pi? Well, if you divide 2 pi by 2, you should just get pi. So that's saying here that, from 0 to 180, the length is pi, or you could think of this way, pi is equal to 180 degrees. And this part is a little bit more important. So anytime you think of pi based off the unit circle, it's actually 180 degrees. And so we'll talk about that in our next slide to help us convert. So when we're converting from radians to degrees or degrees to radians, we need to just remember that pi, we said in the last time, is equal to 180 degrees. And so we can create a ratio that helps us convert just like what we did when we had the feet to inches. We created a ratio saying that 1 feet is equal to 12 inches or 12 inches is over 1 feet. So if I have radians already, if I'm given radians, by the way, radians are written with pi's. When you see something that's in radians, it's often written in pi form or has a pi attached to it. So if you want to try to get rid of radians, the denominator needs to be pi. So that way you could cancel out the radians and the pi. And then if you want degrees, then 180 needs to be on top. So notice how I'm writing this equivalent as a ratio. So 180 is equal to pi. And so when you use this formula, you're able to get your degrees, your radians converted to degrees. And same thing if you have degrees, then you want your bottom to be in degrees and then your top to be in radians. So I'm going to put the pi on top. So I'm going to demonstrate how to use this by starting with converting here. These are some homework problems that I've grabbed. This one's in degrees and you're converting it to radians. So to do that, I need to use the second formula because I'm converting to degrees to radians. So I'm going to start by multiplying by the ratio for pi over 180. So I need 180 to be in the bottom to cancel out with the degree sign and pi to be in the top. So if I'm working this out, I already noticed like the degree sign will cancel, right? And so if I multiply this straight across, 60 times pi is 60 pi over 180. Well, if I try to reduce this, I just have to ask myself, 60 and 180, what divides into 60 and 180? Well, that's 60. 60 goes into 60 one time. 60 goes into 180 3 times. So I really have 1 pi over 3. Or you can just see it as, well, 1 times pi is just pi. So pi over 3. And so now I just have this as my answer, pi over 3. So apparently at 60 degrees, it is just really pi over 3 in radians. And 30 degrees, I would do the same thing. I would convert. Remember, degree sign needs to be in the bottom to cancel. And then pi in the top. So if I multiply, the degree sign cancels. If I multiply straight across, 30 times pi gives me 30 pi. And then 180 in the bottom. If I try to reduce the fractions, 30 and 180. Let's think about it. 30 and can go into 30 one time. 30 can go into 180 6 times. So if I were to work this out, 1 times pi gives me pi. The bottom here is 6. And so there we have our new ratio. Or new, we've converted our degrees to radians. Last but not least, we have 90 degrees. So again, I'm doing the same thing here. I'm going to multiply it by pi over 180 degrees. The degrees, because they're diagonal from each other, they're going to cancel. The degrees will cancel, at least the signs will. And then 90 times pi, 90 pi over 180. What number divides into 90 and 180? Well, that's 90. 90 can go into 90 one time. 90 can go into 180 2 times. So if you work this out, 1 times pi gives me pi. And then the bottom here is just a 2. And there we have our new form in radians. So the degrees has now been converted to radians. So apparently, 90 degrees is pi over 2. All right, so let's take a look at our other problems on the homework when we're converting from radians to degrees, so doing this kind of backwards. So let's move to our next slide. So in this case here, we have pi over 3, and we are wanting to convert this radians into degrees. Well, first, we said that, 180 degrees is equal to pi, right? So this time around, I want to cancel out the pi or the radians. So that means I want to multiply this where pi is on the bottom to cancel out diagonally, and 180 on the top, 180 degrees. So because the pi here, when I'm multiplying by this ratio, this is going to cancel out the bottom. But then when I look at this 180 over 3, if I multiply this, remember, when you cancel out things, you always leave behind a 1, right? So 1 times 180 gives you 180 degrees. 3 times 1 gives you 3. And if you divide 180 degrees by 3, you get 60 degrees. So apparently pi over 3 is 60 degrees. And I actually think we found this in the last slide. All right, let's do a tougher one here. So this one's 7 pi over 4. So same thing, I want to cancel out this pi, so I know I need to put the pi in the bottom. Let me do that again. Pi in the bottom, 180 degrees on top. So the pi's will cancel. If I multiply straight across, 7 times 180 gives me 1260 degrees, and then that would be 4 in the bottom because this would just turn into ones. So 1260 divided by 4 gives me 315 as my degree. So I've converted 7 pi over 4 to degrees, which is 315. The last one here, I'm going to do the same method. I'm multiplying the bottom here by pi, and the top here is 180. If I multiply, the pi's cancel. Then I would have negative 1 times 180. Negative 1 times 180 is negative 180. And then the bottom here is 6 times 1 gives me 6. If you divide, you have negative 30 degrees. All right. And so in this case here, I have all 3 of my radians converted to degrees. Okay, that's it for today's journal. I hope this made sense. If not, let me know if you have any questions.